I'm going to let you go ahead and open up your book on 105. 105, if you remember, was volume, surface area, those types of problems we were looking at. We did A through D. We stopped at the tuna can. We are on E, a golf ball. Now, how appropriate. A golf ball, diameter 4 centimeters roughly. The diameter of golf ball is 4 centimeters. Find the surface area of a golf ball to the nearest square centimeter. So the other day we talked about the surface area of a sphere is the same as the lateral surface area. So if you forget the formula, you don't have to write this down, but if you forget the formula, you can remember lateral surface area was the circumference, which is 2 pi r, and the height, which was 2r, 2 of the radius. Remember the diameter of the ball? So if we multiply these out, area equals length times width, 2 pi r times 2r, area equals 4 pi r squared. That's the same formula you can see on page 734. So the surface area, we did this last week, surface area of a sphere, area equals 4 pi r squared. If you can't remember it, you can think about how to find it. So 4 pi r squared, area equals, r is 2. Area equals 4 times pi times 2 squared. Area equals 4 pi 4. Area equals 16 pi centimeters squared. That's my exact answer. But they want us to use 3.14. So, if pi is 3.14, area equals 16 times 3.14. So I get 50.24. Do the directions ask for anything specific? What do they ask?
Nearest square centimeter.
Nearest square centimeter. So I'm going to look at the 0. 2 says to go down. So 50 centimeters squared. So in a golf ball, the surface area 50 centimeters squared. Now, that is if the ball was a perfect sphere. But a golf ball has a lot of dimples. What do those dimples do? Those dimples actually create more surface area, causing the ball to stay in the air longer. It adds drag in certain ways. If you can find a new way to dimple a golf ball, you can create it to fly further. There's a lot of technology that goes into a golf ball. Weird. All right, so we got that. Make sense? All you got to do is plug it in the formula when it's a sphere. So F, if the figure in problem B is attached to the figure in problem A, what is the total surface area of the combined figures? Okay, now, we found the surface area of both A and of B, right? Can we just add those two together? Why not? Yeah, that's a great way to describe it. If we just added the two surface areas together, there's two sides that are touching each other that are now on the inside. It's not part of the surface area. So what we're going to do, since it's been a while, we're going to do the surface area in the method of let's find the area of the base, and then let's find the area of the giant wraparound rectangle. So this is our review for that area problem. So as I look at problem F, is this F? First thing I'm going to do is I'm going to draw the base. So when I look at problem F, I've got a base that is, well, I can draw it just like they have it. My base is the trapezoid. Because remember, base is a shape that stays the same all the way through. 6, 4, 12. I'm going to put 10 there. I don't really need it. I'm going to put 10 there because I will need it later. What's the area of a trapezoid? Yeah, 1/2 of the quantity, base 1 plus base 2 times height. So base 1 is, which number would base 1 be? One of two. Yeah, it'd be either 12 or 4 because it's got to be the parallel side. So base 1, 12, base 2, 4, height is 6. 1/2 of 12 plus 4 times 6. Area equals 12 plus 4 is 16. Half of 16 is 8 plus 6 is? Oh yeah, sorry, 8 times 6? 48. So we know that that base is 48. If we wanted to find the volume of that shape, we would multiply by how many layers there are. You can see there's 10 layers. But we want to do the surface area. So now we have the giant wraparound rectangle. The height of that rectangle is the same as the height of the prism. And how do I find the length of the rectangle? Do you remember? Perfect, the perimeter of the base. Perimeter equals 12 plus 10 plus 4 plus 6. 4 plus 6 is 10, 20, 32. So if area is length times length is 32 and width is 10, area equals 32 times 10, area equals 320. So now the total surface area would be what? Juliana, how would I find the total surface area? Add 320 and 48. Is that it? You're close. What would be the one thing you're missing? Does that make sense? Yeah, because we got the front and the back, or we got the top and the bottom, the two bases, so we're going to add 48 twice. 8 plus 8 is 16. 4, 8, 9, 10, 11. 416. And that becomes 416 inches squared. And we took care of answering G before we did the problem. So we are finished with those. Hopefully those make a little sense. Let's look at 106. Lesson 106, the biggest thing today we might have to define some things. The first one is solving literal equations. Solving literal equation. So let's define this so we know what we're actually solving. A literal equation, these are equations of only letters and no numbers. Okay? So as we look at solving literal equations, let me give you, let's go with two different possibilities. I'm going to use blue. I'm going to use black. Let's say I have 2x plus 8 equals 18. How would you go about solving this problem? Sure. We're going to minus 8 from both sides. So we get a 2x equals 10. And then 5 by 2 on both sides. X equals 9. So what happens today, we take a literal equation. Let's change this up. And we're going to say I have ax plus b equals c. I can solve for any of the letters in this. Okay? So let me real quick write the same thing next to it. AX plus B equals C. When we do little equations, they're going to tell us which letter to solve for. So like here, they might say solve for X, or they might say solve for B. We follow the exact same rules. The only difference is there's only letters and no numbers. So, as I look at this one right here, if I had AX plus B, I'm going to rewrite that. AX plus B equals C. Now I want to get X all by itself. Over here, I remove the 8. What am I going to remove over here? That's exactly it, the B. So I'm going to subtract B. So now I have AX equals, who said C minus B is A? Can I subtract C and B? Are they like terms? No. So I can't subtract them. They're not like terms. So I get C minus B. That's what it is. Now over here, I divided by 2. How do I get X by itself here? Divide by A. So X is C minus B divided by A. And that's what the answer is. That's what X becomes. It pretty much just stays right there. So now this one right here wants us to solve for B. So I have an AX plus B equals C. Over on this one here, you don't have to draw on this one, but how would I have removed the 2 and the X from this side? Don't write on it. I would have subtracted. I would have done over here the same thing, subtracted. So 2x minus 2x would have left me with 8. Equals 18 minus 2x. Now that doesn't help me much in this one, but it will in this one. If I want to get B by itself, I'm going to remove my, this from both sides. AX minus AX is gone. B equals C minus AX. That's solving literal equations. Which takes us to the second part of this lesson. Part 2 of the lesson is transforming formulas. So let's think about some of the formulas that we know. Formulas that we know would be, let's do some simple ones first. Area equals length times width. Or circumference equals d pi. Or let's do triangle. Area equals 1/2 of base times height. I'm going to use blue to show what I want to solve for. I want to solve this one for L. I want to solve this one for D. And I want to solve this one for H. Nope, I wrote B. So I'll solve that one for B. So now we follow all of the rules of multiplication. So maybe what happens is, Larry he wants to fence in because he's buying chickens. He wants to fence in an area that is 30 square feet. He knows he's got 5-foot section, 2 5-foot sections. He wants to know what the length's going to be. Does that make sense? So what we would do is we would solve this one for L. We have L times W. How do I get L by itself? Yeah, the inverse operations. Divide this side by W, divide this side by W. Area divided by width is equal to what my length is. Oh. That's transforming a formula. Circumference equals d pi. I want to get d by itself. What do I do, Sebastian? Divide by what? Okay, so if I divide both sides by d, I get c over d equals pi. I don't think I got d by itself. Very good. If I divide this side by pi and this side by pi, circumference over pi, pi cancels, equals d. So in the triangle formula, let's get rid of the half first. How do I get rid of half? Taylor? I could divide by 1/2 or, yeah, multiply by the reciprocal, right? So I'm going to multiply this side by 2 and this side by 2. So 2 times A equals base times height. Now how do I get B by itself? Two A over H equals B. So really this is a how well do you understand the rules of algebra? Let's take one big one. Let's take the formula we just used. I want you to solve for B2. I'm going to give you a quick chance to try to solve for B2 first. Before I do it, what do you get for B2? Get rid of the half first. Go 30 more seconds to give you a chance. 30 more seconds. Before I solve it, I want to point out a couple things. Well, actually, one thing in particular, right here. The only way that can even happen is A cannot be 0. Because you can't divide by 0. So I just want to point that out. When I look at this one right here, again, W cannot be equal to 0. We know pi is not equal. H cannot be equal to 0. Because anytime those are equal to 0, we get something that's not true because you can't divide by 0. So Camilla, what's the first thing you're going to do to solve this one? I said get rid of the half first. How do I get rid of half? No, because half's being multiplied, so I cannot subtract it because it's being multiplied. How do I undo multiplication? Division or the inverse. So instead of dividing by half, I could multiply by. So I'm going to multiply the entire side, because it's not just the number. We're multiplying the entire side by 2. So this becomes 2 times a. And just to see what we have here, we have 1/2 times b1 plus b2 over 1 times h over 1 times 2 over 1. That's what this says. So tops and bottoms can cancel. I'm left with everything that's left. So base 1 plus base 2, still in parentheses, times height. How do I get rid of the height? Because that would be the next thing I have to get rid of. What do I need to do?
Divide both sides by h.
There you go. Divide this side by h, and this side by h. 2a over h, because the h's cancel. If you don't have it, sit down and fix it. Equals b1 plus b2. Now I want to get the b2 all by itself. I look over here. The only thing that's happening is I'm adding b1 to it. How do I get rid of adding b1? Subtracting b1. Minus b1 from both sides. So this is a term, 2a over h, minus b1 equals b2. That's my final answer. It's this entire term here minus the b1. I don't expect perfect on that one. It'll take a little bit of time for us to get used to these, but if you know the rules for algebra, you apply them even if there's no numbers. Okay? Have a seat. All right, 106 has another section. Roots. We've spent time doing square roots. Okay? But if I look at the number 25, has 2 roots. I'm going to say 2 square roots. Okay? I don't, yeah, let's do that. So 5 times 5 is 25. Negative 5 times negative 5 is also 25. Does that make sense? But the square root of 25 only equals 5, not negative 5. Okay? So if we put this in words, 25 has 2 numbers that can be squared to equal 25. But the square root of 25 is only, equals only 5. So it's really going back and forth thinking the two ways. I need you to open up to page 740 if you're not there. And we're going to look at how they best word it. 740. On page 740, it says the perfect square of 25 has both positive and negative square roots. 5 and negative 5. Because 5 times 5 is 25, and negative 5 times negative 5 is 25. So the equation x squared equals 25 has 2 solutions. Kind of left that part out. So x squared equals 25 is asking the question, what number times itself is 25? So in this case, x could be 5 or negative 5. The positive square root of a number is sometimes called the principal square root. So the principal square root of 25 is 5. The radical symbol implies the principal square root, so square root of 25 is 5 only and does not include negative 5. Okay, so you put it behind here. The principal root is what we're looking at. So looking at example number 4, it says, what are the 2 square roots of 5? Now 5 is not a perfect square, is it? So when we look at 5, the square root of 5 and the negative square root of 5. Square root of 5 times square root of 5 equals the square root of 25, which is 5. That's where we got the 5 here. Negative square root of 5 times negative square root of 5 is a negative 1 times a negative 1 times the square root of 5 times the square root of 5. Negative 1 times negative 1 is 1. Square root of 25 equals 5. So both of these, square root of 5 and square root of negative 5, would be able to be multiplied to get 5. You're going to mess that one up even next year as we look at that. The more we do it, the better it is. This is kind of just an intro to you. Look at what this might look like if we did work with it. This is not in your book, but x squared plus 7 is equal to 16. So let's first solve this one mentally, okay? Something plus 7 equals 16. What does this something have to be? What plus 7 is 16? 9. Okay? So we know that this, don't write this down, we know this is going to be 9 plus 7 equals 16. We know that's going to be 16 equals 16, right? So then what we're going to look at is, if x squared equals 9, what could x be? Because 3 times 3 is 9. Anything else? Negative 3. So if we came over here and did the math, x squared plus 7 equals 16, and we subtract 7, we get x squared equals 9. Seeing the squared makes me think, what 2 numbers can I get? Now we would show that work. It's inverse again. I undo this by doing x squared equals, and I always put a plus or minus. When I do the square root of an x squared, I bring over a plus and minus. So x equals plus or minus 3. Because there's 2 values it could be. So we looked at one more. Let's say x squared minus 6 equals 30. We'll go a little simple one there too. How do I get x squared by itself? Add 6 to both sides. So x squared equals 36. I see the x squared, so my head says 2 answers. So the square root of x squared equals a positive negative square root of 36. So x is a positive or negative 6. 2 answers, a positive 6 and a negative 6, would both make that statement true. That good? All right, and then the book also talks about cube roots. What number times itself 3 times. So when I look at my cube root of 64, just a reminder, this number here is the radicand. This number here is called the index. And the sign is called a radical. So just like in square roots, we were looking to pull out 2's. In cube roots, we're just looking to pull out 3's. And that might look something like this. Take 64, factor it, it's 8 and 8, 4 and 2, 2 and 2, 4 and 2, 2 and 2. So we get the cube root of 2 times 2 times 2 times 2 times 2 times 2. Because there's 1, 2, 3, 4, 5, 6 2's. So because there is a 3, I take out 3's. Every time there's 3 numbers, I pull it out, pull it out, pull it out. My answer is 4. The cube root of 64 is 4. And that kind of makes sense too, because cube root of 64 is 4 times 4 times 4. 4 times 4 is 16, so we can pull that out. Now if I did the square root of 64, and we follow that same principle, when there's no number, there's a 2. But if I put 2, 2, 2, 2, 2, 2, all of the 2's there, because square root has a 2 and this is a 2, I pull out the pairs. 2 times 2 times 2 is 8. Because 8 times 8 is 64. Stand up and stretch it out real quick before we jump to those practice problems. Actually, I might save those practice problems for tomorrow. Let's do just a couple of the practice problems. Sound good? Juliana, stand up for me. We need to get moving. Are we good? All right, have a seat. So practice problem A for this lesson. We got solve for A plus B equals C. A plus B equals C. That's a lot different than our formula for the area of a parallelogram. If I want to solve for A, how do I get A by itself? A equals C minus B. And that's it. Wx equals Y. Solve for W. Noah, what you gonna do? Yeah, I'm gonna look at what's happening in W. I'm multiplying by X. To undo it, I divide by X. So W equals Y over X. C. Y minus B equals MX. Oh, that's coming. Y minus B equals MX. We're going to solve for Y. Sebastian, what do you recommend? So a negative 1B minus 1B is negative 2B. Did that help? How do I undo subtraction? Add. So I'm going to add B. This equation, y equals mx plus b, that's the equation of a line. Okay, so this is my answer for this one, but what I want you to hear is m is my slope, and b is my y-intercept. That'll mean something to you coming up. The y equals mx plus b, that is the equation of a line. Problem B. So the formula for the area of a parallelogram for B, area equals base times height. Area equals base times height. They do some easy ones. They want us to solve for B. Let's see, how would you get B by itself? Yep. Area divided by height is my base. E. Square roots of 16. What two numbers multiplied by themselves gives me 16? 4 negative 4. But the square root of 16 is only 4, the principal square root. Good. Yeah, we're going to finish these. F is the cube root of 125. If we go back to how we did 5 times 25, 5 times 5. So the cube root, 5 times 5 times 5. Because of the 3, I pull out groups of 3. I have a group of 3. The cube root of 25 is 5. G. Cube root of negative 8. Let's put the negative aside real quick. Let's go with just 8. What number times itself 3 times is 8? So really, with the cube root, what can happen? You see that? Because negative 1 times negative 1 is positive 1 times negative 1 would be negative 1. Negative 1 times this is 8. We could then pull out a 2 and pull out a negative 1. Gives me an answer of negative 2. Or we could have said this is negative 2 times negative 2 times negative 2. There's my 3. My answer is negative 2. So just two ways to look at that same problem.